X, Y, and Z are non-zero positive numbers satisfying the relationship 2x by 37 is equal to 2y by 43 is equal to z by 19. And we are given two quantities. The quantity A is x plus y and the quantity B is 2z. And we are asked to find the relationship between the two quantities. Now, this is a common quantitative comparison type of question that's asked in standardized tests like GRE. And one recommended method that I saw and which I didn't like that much was, really plugging in different values of x, y, z and comparing the quantities A and quantity B and trying to see if one is consistently greater than the other. The reason I don't like this approach is because this is kind of a trial and error kind of approach where you plug in different values and you can never be sure because just because the relationship looks a certain way for a certain set of values of x, y, and z doesn't necessarily guarantee that the relationship will hold for every other value. Plus, it's time consuming to plug in values and test the quantities. So there is actually a trick to solving these kind of questions, which I have probably described in a previous video as well, but I think it's worth revisiting and emphasizing the trick. So whenever you see a equality with three or more quantities, a common trick which may simplify a lot of these problems and make it a very elegant solution to these is assign a common variable to that equality. So in this case, we just let 2x by 37 is equal to 2y by 43 is equal to z by 19 equal to k. And of course, since these numbers x, y, z are non-zero positive numbers, k should be also non-zero and positive. So k would be greater than 0 in this case. Now, once we do that, we can express each of x, y, and z in terms of k. And in this case, 2x will be 37, 2y will be 43k, and then z will be 19k. Now, if we look at the quantity A, it's x plus y. Now, if we sum up 2x and 2y, then we get 80k. So that's a simple sum of those two quantities in terms of k. And then if we divide by 2, we get x plus y. So we have the quantity A. Now the quantity B is 2z. So 2z, z is 19k, so 2z will be 38k. So since k is greater than 0, then obviously 40k is going to be greater than 38k. So that means that x plus y will be greater than 2z, and your correct choice will be option A. So this kind of approach is simple, elegant. It avoids, plugging in different values and testing, which may be a little bit longer method in this case. And it's not a good, mathematical way to solve the problem. Plus, the approach, this kind of approach, makes sure that your relationship is kind of universal. So it holds for all possible sets of values of x, y, and z that the problem allows. So that's why I recommend doing these solutions, because they're time saving comparing to plugging different combinations of x, y, z and examining the relationship, which works well in some cases, especially when the relationship cannot be determined. That's one way to know, because if we find a certain relationship for one value of x, y, z and we don't find that same relationship for another set of values, then kind of that gives you some clues that the D might be the correct option. But in this case, it just appeared that solving the problem the correct mathematical way is so much more elegant, straightforward, and gives you an easy way to figure out the relationship. So going over to the next problem, and again, so this is an exponents problem, which looks complicated. So we have x to the power a is equal to y to the power b is equal to z to the power c, where x, y, z are unique positive numbers and a, b, and c are non-zero. And we are asked to find what's the value of this expression, right? And one thing that we note here is there's an equality that involves three or more quantities, and like I said, a preferred approach in many of these problems is to just assign that equality to a common variable k, and then express x, y, and z in this case, which are the variables, in terms of k, which you can do pretty easily from exponents. So if x to the power a is k, then x will be equal to k to the power 1 by a, and similarly y will be k to the power 1 by b, and z will be k to the power 1 by c. So now let's take a look at the expression that we have been asked to find the value of. So if we take the brackets out and just separate the numerator and the denominator, this is what we end up getting. So in the numerator we have x to the power 1 by c multiplied by y to the power 1 by a multiplied by z to the power 1 by b, and similarly in the denominator we have y to the power 1 by c multiplied by z to the power 1 by a multiplied by x to the power 1 by b. Now, since we already know what x, y, and z are in terms of k, right, and we could easily evaluate these exponents. For example, x to the power 1 by c will be k to the power 1 by ca, and similarly we can write x to the power 1 by b will be equal to k to the power 1 by ab, and y to the power 1 by a will be k to the power 1 by ab, y to the power 1 by c will be k to the power 1 by bc, and so on. Z to the power 1 by a will be k to the power 1 by ca, and z to the power 1 by b will be k to the power 1 by bc. So now we have all the quantities in the numerator and the denominator expressed in terms of k. So all we need to do is just substitute, and if we do that, this is what we end up getting. And from this one, it's actually pretty easy to see that we basically have the same quantity in the numerator and the denominator. So it's the product of the same three quantities in the numerator and the denominator, which means that the numerator and denominator are equal. So the quantity will be evaluated as 1. So so the answer will be this quantity that we're given to evaluate is equal to 1.